And thank you, General. The chair recognizes Mr. Posey for 5 minutes.
Thank you, Madam Chair, for holding this hearing on deep space exploration that involves going back to the moon and then to Mars, and for accommodating these two great, awesome witnesses that we have here to share with us today. To achieve the ambitious deadline of putting boots on the moon in 2024, I think that we all agree that we all must do everything we can to ensure that there's sufficient funding to do that. I think that's where the buck stops. Will we have the money to do that? And I agree with our esteemed witnesses that both the administration and Congress must continue to fully fund the necessary assets such as Space Launch System, Orion Crew Exploration Vehicle, Exploration Ground Systems, Mobile Launcher 2, and the Lunar Orbital Platform we refer to as the Gateway, to ensure that we stay on track to meet those targeted launch dates. In addition to fully funding the critical space assets, I think we need to ensure safeguards are in place to protect the astronauts from radiation in deep space, as well as the other hazards that are inherent to such missions. And with NASA's strong leadership and a firm commitment from Congress, I think we can do that. The questions, General Stafford and Mr. Young, 10 years ago, the National Academies of Science conducted a review of risk posed by radiation exposure during crewed deep space exploration. They evaluated shielding options, mitigation techniques, and recommended strategies for future missions. Do you think the state of science has changed since the last assessment? And if so, would it be helpful to revisit the subject and seek further guidance or updates?
Well, even though I'm not a medical doctor, let me tell you the information here at the sea level at our latitude. We receive approximately 6 millisieverts of radiation a year. In the space station or in low Earth orbit below the Van Allen belts, you get about 0.6 of a millisievert a day. So in other words, in 10 days, say on board the space station, you get equal to 1 year on the ground.
Wow.
Now, for the 24 of us that flew beyond the Van Allen belts, once you get out there, you get about 2.6 millisieverts a day. So in 2.25 days, you get equivalent to a year on the ground. Now, from this study we did, we had the Department of Energy come into us, and medical doctors from radiation expertise, and they said that they use the term 16 grams per centimeter cube. Well, I think kind of from Oklahoma, different inches per, pounds. So it equates to about 1 foot of water would protect you from all solar radiation. And you could use that 1 foot of water in, say, an inflatable and recycle it. And you have to recycle the water, just like you use 2.2 pounds of oxygen a day, you need about 6 pounds of water a day. That water would be enough to shield you very well from the solar radiation. Now, cosmic radiation is a whole different ballgame, but that's not near as prevalent.
Okay. Ms. Young,
I don't have anything to add.
tough to top that one for sure. General Stafford, as someone who's actually flown a lunar landing module during the Apollo, and I had the honor and pleasure to work as an inspector on the third stage of your rocket back in the day. You have unique insight into what we need to be considering now as we begin to build a lunar landing module for Artemis. And wonder if you could identify the key lessons from the development of the Apollo lunar module that we need to incorporate into the current architecture. May it be key safety, testing, oversight, requirements that are necessary for these complex missions that might stick out in your mind.
Well, you hit on a lot of them right there as far as inspection oversight, but you have to start with, you want to keep things as simple as possible, even though it's a very complex subject to work with. And You can't let anything sneak up on you. And you have to have great quality in everything you do. As I pointed out, I don't, in my own opinion, and also what Mr. Cook said, that I don't think that starting with 8 launches to put a series of 4 small things together is going to be the right way to go. Okay. Let's take an example, the space station. It weighs about 900,000 pounds now, but yet nearly 30% of that weight is in the coupling devices to keep it together. Okay. So you want to keep the things as simple as possible in the units. And say if you have these 4 units, each one has to have a electrical power system, a reaction control system, a docking mechanism on them, all of this, and a propulsion too. So you're, versus just an Apollo, in the lunar module, we had just one guidance system. That took care of the whole thing. Yeah. One RCS system.
Well, that was a miracle, General. You know, almost a miracle. Thank you, Madam Chair. I yield back.